Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon, ladies and gentlemen. We are about to begin our webinar on IR 4.0 for water subsectors, the German experience. Thank you for joining us, and I would appreciate to kindly remind everyone to please kindly make sure that if you have any device nearby the device that you are streaming for Zoom, please kindly put it into silent mode so that we can have a smooth Zoom streaming today. Thank you. Good afternoon, everyone. Welcome to Water Sector Development 2040 webinar on IR 4.0 for water subsectors, the German experience. Ladies and gentlemen, we are just waiting for some participants to come in. Please kindly note that the webinar session is also streamed through Facebook Live on the Malaysian Water Association Facebook page, as well as YouTube Live for the Malaysian Water Association YouTube page. Please kindly share the links that we have disseminated around via WhatsApp communications to your professional and personal networks for extra sharing this afternoon. Thank you. And I would like to remind everyone to please kindly switch off your mobile phones or your devices that you are not using for streaming Zoom, just making sure that we will have a smooth Zoom streaming later on. I'm just waiting for my guests to be able to be connected to audio before we begin. Thank you. Okay, shall we start? Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to our German counterparts, and very good afternoon to our Malaysian colleagues. Ladies and gentlemen, yang berbahagia, Datuk Engineer Abdul Kadir Muhammadin, Chair Task Force IR 4.0 for Water Subsectors. Appreciating Dr. Salma Zakaria, Chair Project Management Committee, who is also attending today. Ms. Julia Braun, General Manager, German Water Partnership. We have Mr. Muhammad Shahafiz Shaharis from the Embassy of Malaysia in Berlin, and our speaker today, Mr. Braunbeck. We also have Mr. Lee Kun Yew, Group Executive Director, the Malaysian Water Association. Distinguished participants from Academy Science Malaysia, Malaysian Water Association, colleagues from Malaysian Water Association, ladies and gentlemen. I would like to bid warmest welcome to everyone to our IR 4.0 Water for Subsector, the German Experience webinar today. Truly appreciate your kind time and energy for joining us today for this webinar, and we are truly honored to have our distinguished speakers from our German counterparts. For your kind information, this webinar will run for 3 days, starting today, tomorrow, and the next day, the 7th of May. And the webinar will run from 3 o'clock until 5 o'clock Kuala Lumpur time. Ladies and gentlemen, we shall begin with welcoming address from Ms. Julia Braun, General Manager of German Water Partnership. But before that, allow me to introduce her. As the Managing Director, Ms. Julia Braun boasts extensive professional experience in the field of environmental services, including 8 years in water management, and is therefore highly familiar with water management issues and market requirements. She also has an extensive experience in project management, acquisition and communication, as well as human resources management. Before joining German Water Partnership in 2017, she has held leading roles in water supply and wastewater disposal companies, developing and managing various projects with municipal as well as industrial cooperation partners. Ms. Julia, the platform is yours. Oh, sorry.
Thank you very much for this kind introduction, and welcome and good afternoon to all the honorable guests and to all the participants in Malaysia. I would like to thank on behalf of German Water Partnership, the organizers and hosts of this event, the Academy Science in Malaysia, the Malaysian Water Association, and also the Embassy of Malaysia in Berlin for approaching German Water Partnership and inviting us and our members, the German companies from the water sector, to participate in this webinar on technologies for Industrial Revolution 4.0 in the field of water and wastewater management. We are very much hoping to be able to support the government of Malaysia in its goal to develop a roadmap for its national agenda on water sector transformation by 2040. An ambitious goal, and yeah, we would like to be a part of it. Our network, German Water Partnership, aims at fostering know-how exchange with the goal to implement sustainable technologies worldwide and to find and deliver solutions for the global challenges in the water sector. And digitalization certainly is one amongst these challenges, and an important one. Our members, experts in their field of technology, are therefore happy to share during these next days some best practices and case studies from Germany, and hope that these will contribute to and be of value for the further development of a roadmap for Malaysia. At German Water Partnership, we are looking forward to be partners to the Academy Science Malaysia and the Malaysian Water Association. And we wish you every success on your way and with this webinar, of course, in this week. Thank you very much.
Thank you very much, Ms. Julia Braun, for the kind welcoming remarks for all the participants. Ladies and gentlemen, we shall proceed to the next agenda. And herewith, we would like to welcome Mr. Muhammad Shahafiz Shaharis, to deliver the opening address. Mr. Muhammad Shah Hafiz has served the Ministry for Foreign Affairs of Malaysia for the past 18 years. Upon joining the ministry in 2004, he has served the ministry in various capacities, including the Europe Division, Institute of Diplomacy and Foreign Relations, as well as Europe Division. He has been previously posted in Bahrain and Senegal. He was posted to Berlin in 2018 as the Minister Counselor. In the absence of the ambassador in Berlin, Mr. Muhammad Shah Hafiz is now serving as Charge d'Affaires since November 2020. Without further ado, let us invite Mr. Muhammad Shah Hafiz to deliver his opening address.
Thank you, Professor Dr. Nohayati. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning and good afternoon to everybody. Yang berbahagia Datuk Insinyur Mr. Abdul Qadir Muhammad Din, Chair of the Task Force of IR 4.0 for Water Subsectors, Ms. Julia Browner, General Manager of German Water Partnership, Mr. Florian Braunbeck, Business Developer Digital Projects of KSBSE and KGAA, distinguished speakers for this webinar, ladies and gentlemen. It is my great pleasure to welcome everyone in another gathering of Experts Mind of the IR 4.0 for water subsectors. And despite this being virtually conducted, I was made to understand that the first webinar series by the Academy of Sciences of Malaysia and the Malaysia Water Association, or MWA, in collaboration with the Internal Water Association, was attended by over 100 participants over Zoom and Facebook Live. And on behalf of the Embassy of Malaysia in Berlin, I am truly honored to be part of this program supporting the Water Sector Transformation 2040, whereby under the auspices of the Academy of Science of Malaysia and MWA, we could all learn from the German experience in leveraging IR 4.0 for the water subsectors in our country. And as Malaysia faces mounting water tensions, with some areas exposed to vulnerable scarcity, declining water quality, excessive floods, etc., this webinar aims to serve as a platform for knowledge sharing between the German Water Partnership and its stakeholders of the potential rise of digital water as a transformational pathway in making the sector more resilient to its customers, while simultaneously fuel the economy development. I was made to understand that this task force aims to develop the IR 4.0 for water subsectors as an economic tool towards transforming the water sector into a dynamic water sector capable of driving the nation's GDP growth in the future. Some examples include measurements of organic loading for environmental tax. Some through process in this regard also include tangible and intangible outputs, whereby cost savings in operation may serve the government some savings for maintenance following the economic drag effect as a return of an investment in IR 4.0 and digitalization for the sector. Meanwhile, meanwhile, the document of Water 4.0 by GWP outlines a holistic approach which lives on and evaluate digital data and inputs into forecasting data from various technical areas, thus allowing a holistic consideration and sustainable decisions. According to GWP, Water 4.0 function does not remain static in the now. Rather, it follows technical developments and uses the new capabilities that are provided within the systemic environment of the sector. The approaches lives on the effect of the entire system and the comparison between virtual and real water systems. I was informed that the program this week aims to provide a reference model for the IR 4.0 in implementation in Malaysia, specifically for the water subsectors. So we would like to obtain information on best practices and case studies of the relevant company and organization, which will be helpful in charting a pathway for digitalization of the water sector in Malaysia. As we can see that this webinar features a total of 7 panelists from Germany with multidisciplinary background and experiences in digitalization of the water sector. Hence, therefore, we shall have the opportunity to learn from renowned experts throughout the 3 days program. Again, on behalf of the Embassy of Malaysia in Berlin, I would like to express our deepest gratitude for all distinguished speakers for making the time to join us in this webinar. I wish everyone a good discussion and a fruitful knowledge sharing ahead. And with that, I thank you.
Thank you, Mr. Muhammad Shahafiz, for the kind opening address for the IR 4.0 webinar for water subsectors, the German experience. Ladies and gentlemen, before we proceed to our first speaker for the webinar program, let me do some housekeeping notes. Here within the chat box, our secretariat, our colleagues, Ms. Vanita and Johari, they have both shared some links for surveys. And then we also have some fun things to do, such as polling, and then which I'm going to launch now. And I would appreciate all attendees on Zoom to kindly participate in the polling before we proceed to the first speaker today, Mr. Kronberg. I'm going to launch the poll now. And I'd like to give you about 1 to 2 minutes to try and answer the polls. It's just some fun facts question just for us to. May I please get some votes? If you can see the poll on your screen.
I'm also just taking it. We have over 41 participants, and from my monitoring, probably my internet is a little bit slow here. Yep, we've got 10 out of 40 answering. About 21% voted. Yep, keep it going. I'd like to bid a welcome to participants joining on YouTube and Facebook Live. Looking good with the poll. More than 80% voted, and ending the poll in a couple of seconds. All right, thank you very much to those who have participated and enjoyed the simple poll questions from us. I shall end the poll now. We shall see the results. Okay. We have questions such as, are you aware of any technology being used for water management? 83% said yes, 11% said no, and then 6% said they don't know. And do you find today's topic beneficial to you and your company? Over 71% said yes. And then
For the next webinar, most people suggesting on sustainability and challenges of water topic. I'll just share the result. So you can see the poll results on your screen. The biggest challenge when it comes to digital transformation would be management, followed by database, cultural resistance, security concerns, and of course, including not knowing where to start. Okay, so I'll stop sharing the poll results. And we shall move to the next agenda, to which we have our speaker today, Mr. Florian Bromberg, and he is a business developer in digital projects for KSB SEM Company. And his session is entitled The First and Easiest Step Towards Water 4.0, Introducing KSB Guard. Ladies and gentlemen, without further ado, let us invite Mr. Bromberg. The Zoom platform is yours.
Thank you so much. Yeah, hi, welcome everyone from my side. Good afternoon to Malaysia. Good morning to Germany. It's really an honor to be here today. You heard it. My name is Florian Braunbeck. I'm from KSB in Germany. I will start sharing my screen in a second. Hopefully you see something. Please let me know if that's not the case. I will also try to have the chat open all the time. So please let me know when you have any questions. So KSB, what are we doing? Probably most of you already know us. We are a manufacturer of pumps, valves, and we provide the coding service to this. So pumps, well, this is pretty much the heart of all water and wastewater areas. To move water, you just need pumps. And this is what we usually do. What we now want to talk today is digitalization of pumps. How can we get those pumps a little bit more digitized, sorry for that, and where to start. Where to start was also in the poll that we just saw. It was pretty much the lowest one, but still it is a problem because it's always great to talk about how to digitize the water management and the water areas and the wastewater, but you have to start at one point, and this is also where we came along at KSB, and this is what we want to talk about today. Our solution regarding this is KSB Guard. This is what I want to introduce to you today. So we're going to talk about what is KSB Guard, what does it look like, what is the system, what does it bring to us, and some reference points. And also we will take a look at the system live. So, as you heard, we are a manufacturer of pumps. The portfolio of pumps is huge. They are really small pumps, like the one we already see on the bottom left, and they're huge pumps. Each pump has its own application field, and well, in the end, you can get all of them from KSB, but this is not what I want to talk about today. So, if you look at the pump on the bottom left, it's a really small pump. It's not expensive. It's not critical. This one is probably, yeah, maybe just in secondary processes in the water industry, like maybe heating of the office or something. Those kind of pumps, you do not have to take much care of maintenance. And as such, you do not want to monitor them closely because you do not do anything with them. You have them all for 30, 40 years, then maybe they break down, you just throw them away. On the other hand, they are huge pumps that cost thousands of dollars, tens of thousands of dollars. And those pumps are highly monitored. There are people who do pretty much nothing else than take a look at these applications and these pumps because all the processes depend on this pump as it is the heart of the whole process. Those pumps are incredibly costly, and you are not allowed to let them break down at any point. So all those little small pipes that you already also see in the slide, this could be sensors. to have the sensors there, it's quite an effort to have them and to implement them in existing systems. But as I said, this pump is really, yeah, it costs a lot, and it's really important for you. You have to take that effort, and this effort is just fine for everyone. What we want to take a look at today is all these middle range applications with pumps pretty much starting at one we see here, but also very bigger pumps, pumps that are usually not monitored at all. You have no clue how those pumps are doing. Not really no clue. Maybe someone is checking by the pump like once a month or something, but what if something happens just in between? So this is where we started at KSP to think, hey, we want to know more about this. We want to digitize this and to bring the data from the pump, all these process data, we want to bring them, to make them visible, to somehow get them. But on the other hand, we know we do not want to spend much money on this. So, well, maybe we as KSP, but no one in the field, no one in the water areas is willing to pay thousands of dollars to have sensors there, which is exactly what we noticed. To have such a pump monitored with cables, you pay around $2,000. In Germany, it's probably even higher. It's rather $3,000 to have temperature and vibration sensors there. So this is where we wanted to start, and we said, hey, this is the first thing that we, as a producer of such pumps, want to also offer digital products to our customers. So this is exactly where I want to start with KSP Guard. What is KSP Guard? KSP Guard is a monitoring device for exactly those kind of pumps and other rotating machinery. It is in the end, it is sensors directly at the machine, and we want to achieve a maximum of availability, transparency, and security. How we do that, we will see that in a second. We know that most of our customers do not only have KSP pumps. We provide our pumps worldwide, also quite a lot in Malaysia. I have great colleagues there, but still not all machinery is from KSP, which is fine. We know that there are some applications where something else than KSP pump is needed. And what we want to provide with KSP Guard is something that is still applicable for those machines. So also if you talk about some vans or something, it's also pretty much a motor and some rotating equipment behind that. And this is also something that you probably have a need in monitoring. So this is also where you can use KSP Guard. And in the end, it's a cloud application. Otherwise, it wouldn't be that much digital, right? And because it's a digital solution, it's a cloud application, there's just no need to be on site, and you have this 24/7 monitoring, which pretty much those machines never had before. So how is it done? How does it look like? How does a system look like? The most important part is the KSP Guard sensor unit. I have one here in my hand. You can also take a look at it. This sensor unit, the name just for all the other units, it speaks for itself. We have sensors in there. Who would have thought? We have a vibration sensor and a temperature sensor in there. And this is not much to talk about, but we always have to put that in perspective. A temperature sensor is, well, pretty much always the same, but vibration sensors is something that we have to talk about. So you all have phones probably. You all have smartphones. You know it. If you tilt your phone, if you're viewing a website or something, you will notice also the screen will tilt. This is a velocity sensor that measured pretty much the G-force of the Earth. This is a vibration sensor. You can imagine these vibration sensors built in your phone are not expensive. They are not really good. Depends, of course. In your phone, they're fine. But with these sensors in there, which costs a few cents pretty much, you don't want to monitor really expensive and important equipment. On the other hand, things that you probably already do, many of wastewater and water associations in Malaysia do, they have those handheld devices for one-time measurements of vibration to check how is your machinery doing at one point. Those sensors cost thousands of dollars. which is fine because, well, you take it from pump to pump. But this is nothing you want to have at one machine 24/7. This is too expensive. This is nothing someone wants to afford compared on how critical and expensive the machines are. So what we have here in KSP Guard, the sensor unit, is a sensor in the really medium range. Just in the middle, let's say, we have a resolution of 1 kilohertz. This is really great for our machines because pretty much all major failures can be foreseen with such a rapid sensor. So this is something that we want to have 24/7 on the pump. Where do we stick that? Where do we put that? Let's jump to the next slide before we jump back in a second. Yeah, well, you have this rotating equipment, those rotating parts inside of the pump, and at one point those rotating parts are as close to the housing as possible, and this is pretty much at the bearing. So this is exactly where we want to stick the sensor. This is where we want to see what is going on. We want to put the sensor as close as to the bearing as possible. So here we see some pumps that are really common in the water industry. I'm quite sure that most of you saw one of those before, and yeah, we see it's pretty much always the same, and it really doesn't matter if it looks like this. There are plenty of pumps and also non-KSP pumps, but they kind of look alike always. And we want to put the sensor as close as to the bearing as possible, because also there we see the damage is coming. Let's jump back. We see there's a cable coming from the sensors to somewhere else, and marked with the 2, we have the battery and transmission unit. So we have a cable. It's not completely wireless, let's say, but it is only wireless wired till this box. This box, once again, the name pretty much says everything. It is that big because it has a battery in there. We know at the pump, most of the time there's some space, so it's okay to put some sensors there, but there will probably not be enough space to put also this kind of black box. That's why we use a cable. And the batteries that are in there are these cells. You pretty sure saw them before, those round, slightly bigger batteries. Those are quite powerful, and they ensure an autonomous energy for these devices for 5 to 6 years. So this means after the first installation, you do not have to take to anything for the first 5 to 6 years. And after that, yeah, well, you pretty much change the batteries as if it would be a remote control for your TV. So once again, 5 to 6 years afterwards. Also in the name is the word transmission. It's going wireless from there, which means you do not have to lay cable through all the to the whole site to PLC or whatsoever. It's wireless. Where is it going wirelessly? Well, it's going to the so-called KSP Guard gateway. The KSP Guard gateway, you see it on the left marked with the 3. It looks like a Wi-Fi router, and basically it feels like it is just that. It has antennas towards 2 directions. One is towards all the sensors, and the other one is towards the mobile network. So this means this is completely out of existing systems. Why do we do that? Well, it's quite easy. We want to start. We want to provide an easy and first step towards digitization. And for that, we cannot rely on, I don't know, Wi-Fi network in every wastewater plant around the world. And with the mobile reception, we pretty much can guarantee that it is possible. So we have a SIM card in there. The SIM card works pretty much, yeah, all around the world, and especially it works for Malaysia. And you can use one of those gateways for around, it depends on the reception, but so far I've made pretty good experience in Malaysia. If you have bad reception, you can only use it for, well, 20 to 40 of those sensors. But if you have good reception, for example, an LTE connection, then there's pretty much no end. I'm pretty sure that you won't have that many pumps or other machinery in one room, which is pretty much the range, like 30 to 50 meter, depending on how much steel and cement and whatsoever is in this pump room, usually where the pumps are. Yeah, this is the gateway. So we just saw 3 hardware components, and well, the timing couldn't be better for you, because in the term of this month we will receive the full certification for Malaysia, which is really great. It took quite a while till we got this, but yeah, this is coming this month, and like this, it's really nice to have this this presentation towards you guys. I also have to tell, we already have quite a few pilot installations in some parts of Malaysia. Also, pretty much all of them in the water area, because, well, pumps are simply quite important in that area. I don't have to tell you that. So, of course, we now have talked about the hardware. We have to somehow also see what the hardware is retrieving. And in the meantime, we have 3 possibilities to do so. The most basic one, the one that's most obvious, I guess, is the KSPGuard portal. So if you go to www.kspguard.net, you will be able to log in if you have some credentials and check your specific pumps. Also, there's an app that you could use for your smartphones and you could download. And because, well, we saw that it's a really big need from our customers, there's also an interface for existing systems. And this is also something that will come more and more. So if you talk about not only the next 5 years, but years after, all the systems that you may have at one side will pretty much merge to one, and you do not want to have 10 different systems. And for this, data interfaces are needed. You need some possibilities to integrate data, and this is provided. This can be done. Also, if you have some data management systems, this is also something you want to feed with this data coming from KSPGuard. I will talk about that later a little bit more. So what does it bring? What is the big benefit of having sensors, having something like this, having an IoT solution for pumps? Well, the installation is incredibly simple. You pretty much just stick the sensor either with the magnet on the bottom of the sensor, or also you can use the two component adhesive that always comes with it to fix the sensor at the pump. You do not need to stop the pump at one point. It can be done in the active operation of the pump. Also, the registration of the pump in the system is done with a few clicks. You just have to fill in some basic pump data. You all know those pump basic data like QH whatsoever. And after this, you're ready to go. So in just a few minutes, you have the first data coming from the pump. We always have to put that in perspective. If you would like to wire sensors to a pump, this would take hours. And then also there would be some efforts on IT side to somehow do something with the data that's coming up. And this is all so much time saving. And in the end, also resources, of course, it's just way cheaper. So what can you do now with the pump being monitored? Well, now you get notified if there's anything going on at the pump. Those pumps, as they are, well, not that inexpensive, still they cost way more in maintenance after that. So there's some noise coming up. Thank you. And with this pump being monitored, you can do your maintenance based on this data. And if there's a malfunction, any data coming from the pump that is not seen as normal, you get a notification coming up as mail or push notification directly on your phone. And this is always done with the highest data protection measurements that there are. So how do they look like? Data protection is something that I thought is a really German thing to talk about. But as I do the business development for this for nearly 3 years now, I noticed this is totally not true. And it is pretty much the same all around the world. So data protection is important. It is even more important when we talk about digitalization. And like this, we just have to take care of this. What we have here, all the measures that are within KSP are pretty much the same that are also in place, for example, at your banking apps, at your mobile banking. I'm quite sure you're familiar with that. It's encrypted. It's at many points there's security to block an access without authorization. And I can really assure you that at no point there's a chance for anyone to get this data. And also, this is now pretty much the most important part, especially for this highly sensitive infrastructure of water. And also there are also the laws. I don't know, to be honest, I don't know the Malaysian laws about this, but the German laws, which are really strict about this, they make sure that there's no access granted to controlling of pumps from the outside. But now we have to think, what is the system doing? Well, the system is sending data of the pump status. What would be the worst case scenario if anyone who would not be allowed actually to get this data receive it anyway? So if someone hacks into that, well, he would pretty much just see pump data. He would just see vibration and temperature data. And this is exactly also why we did it like this. We do not want to have a direct implementation in the customer system, which I'm sure will be there. There will be cloud connections within the next years to control system and whatsoever, but it's not a good way to start at the moment because it's just so sensitive, and you usually do not want this. And this is why we have this standalone solution, not connected to any control of the customer sites. So this is also how we are really able to get in all these water areas in Germany. We have now thousands of installations, and with great feedback from the customers because it's so simple and easy to use. And we started to think of this solution as a solution that is rather used in industrial areas, but as we now have it for 2 years in Germany, we noted, well, the big benefits is rather in the area of water and wastewater, because they usually do not have a solution like this that they are allowed to use. And now for the first time they are, which is great. And this is also, which I'm quite sure is the case for Malaysia. So also the servers that we are using, those are also the highest protection measurements that are existing. There's no possibility for them to be hacked or something, and also the availability is huge. So now for the first time we can do pretty much maintenance based on specific pump status. So not only for those really highly engineered and also pumps with lots of sensors, but also the medium range pumps, and now you can do pretty much all the maintenance based on that. Also directly in the system you are able to schedule all this. You can see all the things that have been done at the pump, and you pretty much see the life cycle of the pump. And whenever there's a bearing exchange, for example, then you can do that. There's a question coming up. It's quite a lot to read. Give me a second. Yeah, I will come to that later. Give me a second. I will pretty much show you how the system looks like and how things are done and managed. Hopefully this will answer your question later. If that's not the case, we will have some time at the end to also have further questions. So what you also have is documents of the pump directly in the system, which means this is a really huge benefit. You now do not have to search for the corresponding documents for hours because you just have them on paper at some place at your office, but you don't know where. You always have this on your phone. For each pump, you have these documents, those sectional drawings, those operating manuals, whatsoever, just there. This, of course, in the basic version, it only works for KSP pumps, of course, because, well, we of course do not have sectional drawing of other pump manufacturers, but it is quite easy to just upload documents of this for your specific pumps, and it's not a KSP pump. Also, which is quite nice to have, is for pumps that do not have a frequency converter, it is possible to calculate the load condition of the pump. The load condition may be familiar to some of you, but not all of you. Pumps are, well, there's a specific point, a specific rate of water going through with a specific pressure, which is perfect for a pump. And if it's a little bit above that or below that, then it's wasting energy. And this is quite a lot of energy. Pump make, depending on which source you use, between 10 and 20% of the worldwide energy consumption, which is incredibly much. And many of you know how much energy and also money within this energy goes into this pump. So if you would know if there are some optimization that is possible, this is a huge benefit. And this can be done with this simple sensor just on the outside of the pump. We could look at this in the system in a second. As mentioned, it is quite important, and it gets more and more important with the time, to also implement data in existing or upcoming systems. There are really lots of developments going on with data management systems, and this is nothing we want to spare the KSP Guard data from being implemented in. So REST API is something, also, to be honest, it was not familiar to me, but this is pretty much the common language to communicate between two systems connected to the internet. And this is available, this is possible. You can, if you do not want to use the app or the web portal, it's quite easy to also implement that somewhere else. For IT guys, they are really familiar with that. I was told within the first year of their training, IT guys can implement REST API calls somewhere else. Oh, there's an echo coming up. If you trade, it should mute yourself.
On the line there, okay.
Thank you very much. So I do not want to wait. If you have questions about this later, please let me know. So what we are now doing is I will shortly stop my presentation of my screen, and I will just show you on the pump how it's done, how easy it is to install it just there. So I will just go there. So what we have here is it's a KSP pump. It's an Etanorm. This is pretty much, it's the most sold pump worldwide in terms of norm water pumps. Maybe you've seen one, maybe you've came across it. Doesn't matter. It's a really, really common pump, and even if it's not an Etanorm, they pretty much look alike, right? So what we're going to do is I will show you how fast it is to have the sensors and also the gateway installed. Earlier, I compared the KSP Guard gateway with a Wi-Fi router, and well, you will now see why. I will plug it in, and this is pretty much all. Oh, just throw things around. Of course, you have to screw the antennas in. As I said, there are two antennas, one towards the sensor network. Give me a second. And one towards the LTE network. And now we'll just boot up. As I said, there's always this SIM card in there that will log into all the major telecommunication networks in Malaysia. And like a Wi-Fi router, it takes 1 or 2 minutes, and then you're ready to go. So let's go to the pump. As I said, we always want to go as close as to the bearing as possible. The bearing is in this area here, so we just put the sensor right there. And also now we are once again done with the sensor. We could now glue it, but as I demonstrated quite a lot, I won't glue it this time because otherwise it would be hard for me to remove it again. So now I just have to plug in the transmission battery unit. There's once again coming some sounds up. It would be great if you could mute yourself. And now we have to just screw it in and we are done. We press the button and it's searching for signal. In the meantime, we also have full reception at the gateway and also at the battery and transmission unit. We now also have full reception for bars. Would be really strange if it would be otherwise. And we're done. This is all you have to do on the pump. And now you just have to go to the system and tell the system, hey, this pump corresponds to this sensor. I won't do that because I'm here at the research department of KSB, and we have a lot of gemmers, and it's actually not possible for me to send any data from there to there because those gemmers are used for some experiments regarding reception and data transmission. But what we still will do now is we will jump just into the system, and I will show you how it would look like. So this is pretty much where we start. This is the KSB Guard dashboard. And what we see here is now 8 pumps running. You see it on the top left, but currently it's only 7 of those 8 pumps running, doesn't matter. Those are pumps that are running in the boiler houses of the KSB sites here in Germany at Frankenthal and Pegnitz. Those are the biggest sites in Germany, doesn't matter. So what we have here, we see how many pumps are on, how many pumps do have a problem, and we also see the load status of those pumps. Well, it's quite impressive to see the load status of our pumps running at our own site, because we always pray to everyone, hey, please use your pumps in an optimum state. And as you can see, well, we don't do it ourselves as well. Let's later take a look at load status and we look at a specific pump. Also, we see what messages came up. Each message is a warning or an alarm that came up at one point. So one thing could be, for example, the vibration of a pump, if it's really high, or the temperature. And also, since we are capable of measuring the operating hours, we also recommend bearing lubrication or bearing replacements. And this is also something the whole thing reminds you of. So let's take a look at the vibration warning. Vibration is always the first thing when it comes to pump malfunctions. So when there's something going on at the pump, way before you can hear something or see something like smoke, you would always see some vibration coming up. Let's move to a specific date back in December of 2019, because at this point we had pretty much the most stereotypical case that you can somehow have. So I can also put the load condition just below so we can see it faster. Yeah, well, in the December the pump was running and then it was switched off. Why was this the case? Looking at the vibration graph, we see the vibration, the RMS values going on in 3 different dimensions. And you probably note what I'm referring to. Let's zoom in. So I'm referring to this peak. You see the orange line and the red line. Those are the warning line, the orange line, and the red line is the alarm line. Those thresholds are set pretty good. As you see, when the pump is running, it always is running below those red-orange threshold. And at one point in December of 2019, something was going on. So as you see, at 9 a.m., for the first time, the vibration value was above the orange line. What happened? Well, notifications were sent to pretty much all users that are somehow close to those pumps, which means it was actually me. I received a notification that there's something going on. And also our maintenance staff received a notification. Our maintenance staff, well, I gave them a call. I called them and said, hey, there's something going on with your pump. Could you please check it? just as maintenance guys maybe sometimes are. They did not immediately check it. They said, well, we have so much things to do. We have no time. We cannot go there at the moment. But maybe we will check it later. Well, I couldn't do much more. So yeah, I just left it like this. And 3 hours later at 12 o'clock, we did not only receive a warning, but also an alarm as it was above the red line. So once again, I got a notification. I got the notification on my phone, and also I got it via mail. And I just took a look at the graph and said, well, this is really alarming. I once again called the maintenance guys and said, yeah, your pump is really getting damage. Go there, switch it off. You have a redundant pump. There's another pump just next to it who could do the job of this pump. This is what happened. They just went there, switched off the pump. This is always a great measurement in preventing some damage. And this has been done. But also just after they did the maintenance that the pump needed, they checked the pump, they opened the pump, took a look at it, and what they found is that inside the coupling, there's a specific ring that was just worn off. This is a really, really common thing that happens to pumps that are, well, pretty much running 24/7. And this ring has to be switched at specific points. So as this ring was worn off, this caused the coupling to vibrate, also to get some heat, but we do not see that in the graph. The thing is, what would happen if the pump was not switched off? Well, the ring would probably be completely destroyed. It would not only be worn off, but yeah, well, let's say gone. The coupling would get damaged. Probably the coupling would not be usable again. And also when the coupling is yeah, well, has a damage and the pump is still running further, probably the bearing would get the damage. What does this mean? Well, let's take a look at the pump. It's a rather small pump, so it's loading. Hopefully, so I have to go somewhere else. I have to click directly on the pump. So it's a rather small pump. If the coupling and also the bearing would get a damage, probably it would be cheaper for us to just switch the whole pump. This coupling, this replacement, the coupling ring, the replacement of this coupling ring, it costs us like just the spare part. It's probably like $20 or $30, and the replacement of this takes, let's say, 30 minutes. So this is what the maintenance, all the maintenance that had to be done were. And well, if this would not have been done and the pump would have to be replaced, this pump probably costs like $3,000. New pump, also the installation, it takes a few hours to install this. Probably would cost around $4,000 to $5,000. So we saved about $4,000 with just this small, yeah, this small device directly on the pump. And this is really, really stereotypical what case we got is about. You see damages way before they come with this really basic data. And the thing is, well, I triggered that. I was not on site. I was not there, but I was able to trigger this because I got the notification on my phone. And this is just the great benefit that we have, and also which, well, digitalization brings us more and more in the future. It saves time, it saves money. Our maintenance guys, which, well, to be honest, we have less and less of those. And they have so much work to do. They really do not mind if something like this takes a little bit from their work, and this will be more and more in the future. So yeah, this is pretty much what the system looks like. I mentioned it earlier. We are capable of having the load condition directly in the system. So let's check the load profile. We see, well, when the pump is running, it is running in part load, which means the pump is too big. It could be a smaller pump, it could be a smaller motor, and as the pump and the motor get smaller, they consume less energy. So let's say we could save like, let's say we could save 3 kilowatts per hour. A kilowatt costs like 20 cents. we could save 60 cents per hour. And you see the pump is running 9,000 hours, 9,000 hours times 60 cents. This is quite a lot of money. This is more money than the pump costs. So even this is really great to have it just made visible, which is usually not that easy without having to interfere in the pump itself. To drill in the pump, usually can only do this with pressure sensors in the inside of the pump. So yeah, this is pretty much what the system is about. This is what it looks like. Let's jump back to our presentation and let's jump back to further reference cases. I hope you still see my screen. Otherwise, please let me know. Let's go into a water area because, well, this was now heating supply. The pumps that were running there were etanoms. These are norm water pumps. These are really common in water and wastewater areas. But let's see a reference case from, yeah, hands-on in the field at some wastewater plant. What we have here is some slurry pumps, pretty much. It's in a wastewater pool, and they pump this slurry stuff for cleaning water. I'm just missing the English word, but I think you may know what I'm talking about. KSP-Guard was installed on these Sevatec pumps, and you can also see it if you look closely. It's on each of those pumps there is this small black box that I presented earlier. Why did they do that? Well, they had a bearing damage pretty much once a month, which is really, really not nice. Bearing damage is something you really want to avoid because it's just so much trouble. It's just annoying to have bearing damages. You have to replace the bearing each time. This just costs money, so much money. So they installed KSP-Guard on, and they realized, well, there's quite high vibration going on in the y-axis. So in the vertical axis, you see the green line. And some of you just may look at the picture and say, well, what is this installation? It's just badly done. And you're completely right. No one noticed it earlier. The data helped us that the y-axis means there's something going on. There's something like a hammer going towards the pumps from above. And it's, of course, the pipe that we see here. The pipe is just lying on the pumps. And this is bad, of course. And the measurements that were done were pretty easy. They just had some structures holding the pipe in place on the ceiling. And also you may see it between the pump and the pipe, there's some rubber now, which means that the pump is running. There's vibration coming from the motor towards whatsoever. This rubber just stops it from going towards the pump, and it stops the pipe from shaking. And now we see it in the graph. We have vibrations going on below 1 millimeter per second. This is huge. This is great. And you guessed it, no bearing damage after that so far. And they had those bearing damages, as I said, one of those pumps had bearing damage each month. And now this is like 1.5 years ago, and they did not have one so far after that. So really small adjustments just based on data. And this just saves so much effort and money. We can see also the rubber between the pipe and the pump here better in this picture, just next to the head of the colleague we can see here. So some more examples coming from wastewater and water areas. One of them really huge problem in wastewater areas, clogging. This clogging can always be seen with vibration going up. So of course there is some clogging that is done that happened at one point, and one specific point, one too big thing just is inside the pump and then it clogs. But many times the problem, this clogging is an ongoing procedure. And this can be seen with upgoing vibration. And at one point you probably are above the warning limit, and this just triggers in many cases, just like in this can trigger the opening of the pump, the removal of whatever is clogging there. And this happened already quite a lot with KSP-Guard, and this just helps having a way smoother processing of wastewater. Also, water areas, we had a really great problem for water areas because, well, what you really do not want to have in water supply is 4 meters, and this is exactly what happened. It was a rather big pump, water pump, and we saw some peaks going on with KSB Guard. They stopped the pump, started the redundant pump, and they saw that the rubber that's somehow from the pump or from any piping or whatsoever was stuck in the propeller of the pump. And yeah, before the pump got completely destroyed by this foreign part that was in there, they were able to stop the pump from running and remove the rubber. This is pretty much it. This is pretty much what I want to show. We have now still plenty of time. I also have more reference cases if that's interesting, but I would skip those to have more times for your questions. Please let me know those. You can just put them in the chat. Maybe also if it's coming from someone who is willing to unmute you, just also feel free to get in touch with me. If you have further questions, please do not hesitate to contact me at any point. It's, as I said, we have already quite a lot of installations in Malaysia, and as the certification will be around in just a matter of weeks, I'm really, really happy to have more of that. Actually, I planned on visiting the whole, South Asian region, but you probably can imagine that it is not that easily possible. Like I just have to do video calls at the moment. So, well, but maybe I will visit at one point. It would be really great. So far, till that point, I can also give you the contact details of a really, really good colleague from there. He's also a KSB Guard expert. He did all the installations there. If you have specific questions about something in Malaysia, just get in touch with him. Are there questions? There's already some quite a lot of chat going on there. I have to take some time to read that. If I'm not quite sure if this is questions towards me.
Yes, Mr. Braunbeck, I think there's a question from Ms. Noor Ashikin there. I think there's one stating good technology. In any event whereby unusual reading recorded as a result of faulty in the equipment, what is the prevention steps to overcome the problem?
Yeah, so you saw that we measure RMS values in the system. Those are great to see that there's something going on, but it is not good to see where's the problem. There's no fault analysis based on RMS. What we can do, what we can provide, and also what will soon be updated in the system is that we have the frequency analysis directly in the system. Frequency analysis, this means a vibration that is going on, something swinging. It is always in a certain frequency. And these frequencies can be analyzed, and they are also measured by KSB Guard, and they can be analyzed to see what's going on. Sorry. For example, if there's some loosening going on, if the pump is not really fixed in place, those vibrations would be rather in a low frequency area because big parts are swinging. And this root cause analysis can be done by us. So if there's something going on, if there's an unusual reading, as you say, the first, I'd always recommend either two things. Either you just check the pump. It always makes sense to, well, use the redundant pump if there is one. The trend is rather going towards, well, less and less redundant pumps. And just check the pump. Usually you have really highly trained staff that probably already knows what's going on if they take a look at it. And the other thing is get in touch with us. We can always provide more information on what's going on. We can also provide the service. This is nothing that I want to sell to you today, but we are proficient in pumps and we know a lot about those, and we can help you there. And this is what I would recommend doing in the future, which is certainly coming, and I cannot tell you when, because this is something I just don't know. At some point, we will have our artificial intelligence to be that far, when we have plenty of people who just work on that, that this artificial intelligence will just tell you what's going on with the pump. So I started this presentation with the title, The First and Easiest Step Towards Digitization. So this is where we start. We start with telling you, hey, there's something going on, and what's coming in the future is this artificial intelligence thing. In the future, the system will tell you directly what to do. So, for example, it could be, please remove the bearing, relocate your bearing, or there's something in your pump, please check by. This is what's the future. Currently, well, it's just local checking of the pump is necessary and cannot be done otherwise. Do you have other questions?
Okay, thank you, Mr. Braunbeck. And I think we have Engineer Zahidin online for his comments. Engineer, would you like to say your comments live?
Okay. Hello.
Hi.
Okay. Hi. Okay. This is one of the good example of predictive maintenance via condition-based monitoring.
Condition-based monitoring is part of a good word.
CBM, yeah. CBM. So basically, it's we save. We can reduce the cost of maintenance and also as well as the energy consumption of the pumping system, right? But actually, when we talk about digitalization, it's not always true that any digitalization projects will improve your energy efficiency or water efficiency of your water supply system, of the pumping system, right?
Yeah.
So basically, we have to go further. We have to go further. Besides, we monitor the pumps. We should also monitor the pumping mains. Because that actually, because we have in Malaysia, we have a problem of water loss problems, water loss problem, and also energy loss problem. So as you can see, we have some of the operators are running at loss. That means their revenue is more than their total expenditure is more than their revenue, right? So basically, we have to address this, both water efficiency and energy efficiency. These two we have to address by monitoring the pumping mains, which is the pipes and piping system, right? We can actually determine what are the water losses.
Completely right.
And also on the energy losses as well, because why in Malaysia they have a lot of I should say that people are not really monitoring these water losses at the pumping system, but it's there. It's not a physical losses. It's just because of the frictional loss in the pipe is already increasing, or there's some blockage, or there's some leakages. It will affect your system curve. That's why we need to monitor system curves as well, so that we can basically improve on the water efficiency and also energy efficiency. That's my opinion.
Yeah, you're completely right. Maybe I add some points from my experiences there. You're completely right. The pump is just it's an important but small part of the whole system. The pipes, the valves whatsoever are also important. And if you want to really increase your efficiency in whatsoever way, it's always the most important, but also the most difficult part to just put everything together. Which means if you have the pump perfectly energy efficient, there could be evolved at some point to just trigger exactly the opposite of what you are doing at your pump. And this is something that we have to work on, and this is something that we will work on in the future and more and more. And it will be a really huge challenge to have a system view on it. But we have to start at one point. And this is also something that we just thought with KSP is great. And we also have with customers a really great example, maybe one last example. At one customer, they saw that depending on certain parameters of the site, they had high variation. just had a data management system. So they fed in the system with KSP guard data, so pump data, with data from the valve, and with system data, environmental data. And then they noted that that at the specific temperature of the outside, a valve just closed. A certain valve just closed at, I don't know, 19 degrees. It was just a malfunction of the valve. It incredibly inefficient, and they just needed the vibration data of the pump to notice this. They just didn't know that this happened. And what then happened is that they put different data together, and this system view just helped them to find the root of the problem. And this is something that will come more and more and will be a challenge in the future. But you need to feed it with data, and this is something that you can have there. But I totally understand what you're saying. I'm completely with you. At the end, what we need is system solutions and not component solutions. Thank you for the comment, by the way. If there are no more questions, then thank you very much from my side. Thank you very much for inviting me. It was really great. It was an honor for me, and I wish you the greatest of health. Yeah, sorry.
We have one more question on YouTube.
Yeah. Okay, all right.
One more. Okay, so this is from Mr. Nick Nasrol, who has been following the webinar from YouTube. He would like to know whether the system can exactly identify the source of vibration and which part of the pump set, is it on the motor or pump side, and then which bearing drive end or non-drive bearing, or just trigger as usual. Thank you.
Great question. Great question. This is pretty much. I'm sure he's a pump expert. Let's start with the last question. It always depends on how closely you want to monitor pumps. Generally spoken, it is enough to have one sensor at the motor side, the drive end bearing of the pump. So pretty much the bearing in the middle. If the pump has multiple bearings, like there's one on the motor and one on the non-drive end, you can equip those also with KSP guard, but it's just a thing of how you like it. Usually one at the drive end of the pump is fine, and it gives you quite good insights. Also, the thing you asked for root cause analysis, this is something that we really work on. The future, in the not so far away future, our artificial intelligence will be able to determine exactly where the damage is. At the moment, you have to rely on an analysis of the FFTs, of the frequency and data that's coming up. This is something that we will soon also provide to directly in the system, in the web portal or in the app, that then also the people on site can do this root cause analysis based on the FFTs. At the moment, we always recommend, hey, just get in. If you have the feeling that there's a problem, get in touch with us. We just provide you this frequency analysis, and with this frequency analysis, we can in let's say 90%, but don't. I'm not quite sure about this. In 90% of the cases, we have experts who do this pretty much all the time. They can determine where the problem, where the vibration is coming up and where it's coming from. I hope this answered your question. Otherwise, let me know, and or maybe write me an email or something. Okay. Thank you for the question.
Thank you, Mr. Braunbeck. And I guess that's all the questions that we have over Zoom and also on Facebook and YouTube Live. We would like to thank you for your very interesting sharing on pump.
Thank you.
To the IR 4.0 for water subsectors. Ladies and gentlemen, before we end the session for today, may I invite everyone to please kindly switch on your video for a virtual group photo so that we can put this on our gallery. I think that's the norm here. So we have over 50 participants, I think 50 participants on Facebook, on Zoom today, and about 20 participants on YouTube and Facebook Live. So I'm going to begin with the first page. So we have everybody now switched on. Okay, count of 3. So 1, 2, 3. And then on the second page, please. Okay, so 1, 2, 3. Okay, so that marks the end of our first day of the webinar on IR 4.0 for water subsectors. And herewith, we would like to give our special thanks to Ms. Julia Browner from German Water Partnership, Mr. Muhammad Shahafiz from Embassy of Malaysia in Berlin, as well as to our speaker, Mr. Braunbeck. And thank you to Yang Berbahagia, Dato' Abdul Kadir, as well as Dr. Salma, and all of our TFC chairs and distinguished participants from Academy Science Malaysia and the Malaysian Water Association. Thank you so much. And we have the second day tomorrow. We have 3 speakers for tomorrow's session, also starting at 3 o'clock and ending about this time around. We shall have Dr. Richard Wesner, Mr. Daniel Martins, and Mr. Christian Zeimer for tomorrow. So please stay tuned, and you can use the same link to come into Zoom, and the session will also be streamed via Facebook and YouTube Live, similarly as today. I wish you a very good morning for German friends, and also a very nice afternoon. Happy breakfasting to those observing the fast. Thank you so much and have a good day ahead. Assalamualaikum and good afternoon. Bye-bye. Thank you.
Thank you. Bye-bye.
Thank you.
Thank you.
Okay, bye-bye.
Thanks.
Bye-bye, Doctor.
Bye. Thank you, Cik Izzaruddin.
Bye.
Thank you, Mr. Braunbeck. Thank you, everyone. Thank you, Engineer Zaidin.
Terima kasih.
Terima kasih. Cik Nordin, thank you so much. Thank you, Hari. Okay, Assalamualaikum. I'm going to leave the session.
Okay, bye.
Okay, thank you. Bye.
Just end ya.
End.